Hello, everybody. We are at the end of our 4th day of this course. Every one of you students who signed up for the class is going to get a failing grade because we have almost no questions. But of course, nobody signed up for this class, so it doesn't really matter. But I think you could probably get more out of your instructors if you were to ask questions. I do have 2 questions that came in yesterday. The first one is from Monica Papej, who's a professor at Oklahoma State University. And Mona asks, not sure I can articulate this well, but is it possible to envision an approach where the components of the transmission cycle, such as hosts, vectors, reservoirs, are used in niche modeling at broad scales, but the transmission risk is evaluated at finer scales in areas of interest for which population genetics, maybe of hosts, vectors, or reservoirs, can be estimated with better and available data? I guess this would be if the question is, what is the transmission risk of disease X in region Y? So this gets into a very touchy area of spatial resolution. I guess I should invite Luis to join us as well. Sorry, Luis, I assume you are watching and wondering why I didn't invite you. But maybe, Lindsay, if you'd like to jump into a bit of an answer to that question.
Okay, so I think that some people are starting to research this area, and it may be that you need to set up a little bit different modeling environment in order to be able to evaluate something like this. And it would probably move into the realm of hierarchical models because you have 2 different spatial scales. You have kind of these broader scale processes acting abiotic variables that you would like to feed into your model as information for your then population dynamics, which are happening at the finer scale. So I think that there's a good book by Andy Royal and others that are starting to kind of look into making these links between these different spatial resolutions. The other thing that is necessary to think about when doing something like that is not only is your environmental data at a different scale than your population dynamics, if you would like to kind of estimate across an area the population abundance of, say, a mosquito species, then you need to also figure out how you're going to estimate this population abundance in an area rather than at a point. So you'll have your broad scale climate factors driving into your population model, which you need to have some kind of link function that accounts for that different scale. But then you have to also have an estimate of area rather than point to make a estimate in the niche environment in geography of what the abundance might be. So, yeah.
So a more kind of basic answer to the same question might make mention of what's called the modifiable areal unit problem. And this is essentially a question of propagation of error whenever we have different, it could either be spatial resolutions or even orientation and positions of the same resolution grids. But essentially, any spatial statistic, which might be a mean value, or it might be any measure of a landscape that you would want out of your models, those spatial statistics will depend on the coincidence of the resolution and position of the essentially the system over which you're working. So in response to Mona's question, you're going to be struggling against the contrasting spatial resolutions. And it's very important to resist the temptation simply to just do it and get some results out, because that contrast in resolution is going to make for a lot of artifacts sneaking into your final results. Okay, a second question that we have. Luis, you're with us now?
Yes, sir.
Okay, sorry that I forgot to invite you onto the Hangout. No offense intended. Second question we have, and this is directed to Luis, and this is from Daniela Po Munoz, a friend of Luis's and mine from Chile. Daniela asks, hello, I have a question related to model evaluation, and then she puts Luis Escobar in parentheses. How can I decide how to divide my study area for evaluation and calibration? For example, should I have 2 areas for calibration and 2 for evaluation, or 3 and 4?
Thank you, Daniela. The evaluation, the design of the evaluation is very dependent of each study. So it depends of the number of points that you have, the autocorrelation between the points, and I guess that what I should say is that you must do a challenge for your model, but you must give some chances for the model to prove you that it's working well. For example, if I'm going to design a study in South America, I could split the points, but what if I calibrate the model in the Amazons, but I'm going to evaluate the model in the Andes? So definitely the model is going to fail to predict the evaluation points in this scenario. So I must give some chances to the model to split the points considering the environments available for the calibration and for the evaluation. So that's like the approach I guess.
So maybe another way of saying exactly the same thing is when your input data are biased with respect to geography, it doesn't make much of a difference. But when your input data are biased with respect to the environment, which is to say if the data you put in are systematically biased against certain environments, then those biases will be reflected in your niche model. And so, you know, remember what I did in Nigeria was right half versus left half, or top half versus bottom half. And that's actually a little dangerous when there are strong environmental gradients, because you may create a bias in your input data simply by using these spatial splits in your data. So if you're going to use spatial splits, you need to use enough of them that you break up environmental gradients that underlie the broader distribution of the occurrences of the species, and as Luis put it, give your model a chance to get the right answer. And then, you know, probably commonly you'll also want to develop a pure random sampling, which is equivalent to very, very fine spatial splitting. So those are the 2 questions that we have received up till now. If you look at the schedule for tomorrow, it's pretty open. So if you have larger questions, or if you have details that you would like us to go into greater depth on, email us now, soon, and we will flexibly change the schedule for tomorrow. I have some things that I've thought about putting into the slots that we reserved for tomorrow. So it will certainly be an interesting day, as have been all of these. But we wanted to leave some flexibility for you to say, hey, I'm interested in this. Can you please go into greater depth? And we can do that. So again, email me your suggestions or your requests, and Obviously, the sooner you do that, the better we can prepare for that. But tomorrow we'll have some views from 35,000 feet or from 12,000 meters of the broader challenge of marshaling biodiversity information towards public health applications. So we will see you tomorrow morning at 9 a.m. our time, 3 p.m. London time, 5 p.m. Nairobi time. So see you all soon.